Hi everyone. In today's lecture, we are going to see uh, what is the bandwidth of the amplitude modulated wave and the power utilized by the amplitude modulated waves. So before going to that, let us see some basics of amplitude modulation. So amplitude modulation is defined as the amplitude of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal. That means the amplitude of the carrier signal containing no information varies as per the amplitude of the signal containing the information at each instance. So your carrier, which is not having any information, that is varied in accordance with the information signal which is uh, present. So one more point here is we want to transmit the message signal or the modulating signal, so which has the information, and this information signal is a low frequency signal and your carrier signal is a high frequency signal. So we are modulating our carrier in accordance with your message signal. So let us see what is the output when we do the modulation of the message signal. So if you look at here, the message signal, which is a low frequency signal defined by m of t, is equals to am cos of 2 pi fmt, and your carrier signal is a high frequency signal, which is defined by c of t is equals to ac cos 2 pi fct. So when we modulate using the amplitude modulation, then the modulated wave looks like this, where your mu is less than 1. That is, the modulation index is less than 1. Then the output waveforms look like this. And it is defined as S of t is equals to AC into 1 plus mu cos of 2 pi fmt into cos 2 pi fct. So this is the standard equation of your amplitude modulation. Now, let us calculate the bandwidth of the modulated wave. So how the bandwidth is defined? So bandwidth is defined as the difference between the highest and lowest frequency of the signal. That means the highest frequency component of the modulated wave minus the lowest frequency of the modulated wave, which is mathematically represented as bandwidth is equals to fmax minus fmin. So already we have seen in the previous slide, the standard equation of your modulated wave is S of t is equals to AC into 1 plus mu cos of 2 pi fmt into cos 2 pi fct. So when we expand this equation, we'll be getting, or we multiply AC and cos 2 pi fct, we'll be getting AC cos of 2 pi fct plus AC mu cos of 2 pi fct into cos of 2 pi fmt. So if we apply the formula like cos A cos B formula here, so then cos A plus B, you'll be getting a formula here that is cos of A plus B plus cos of A minus B. So cos A cos B is nothing but cos of A plus B plus cos of A minus B. So if we rewrite that equation, the first term will be as it is, that is AC cos of 2 pi fct plus AC mu by 2 into cos of A plus B, that is cos of 2 pi fc plus fmt plus AC mu by 2 cos of A minus B, that is cos of 2 pi fc minus fmt. So this is the equation what we got from your standard modulating equation. So now, what are the terms which are present in the standard equation means? The first term, whatever you see, that is nothing but your carrier. And the second term is nothing but the upper sideband. This is the upper sideband. And the third term is nothing but your lower sideband. Lower sideband. So it is having three terms. One is a carrier, one is the upper sideband, the other is a lower sideband. Now, what is the maximum frequency we are having? The maximum frequency is nothing but your fc plus fm, and the minimum frequency what you have is your fc minus fm. So now let us calculate the bandwidth. So hence here the amplitude of modulated wave has three frequencies, as we said. Those are nothing but your carrier frequency fc and your upper sideband frequency fc plus fm and lower sideband frequency fc minus fm. So the maximum frequency is fc plus fm and the minimum frequency is fc minus fm. So from your previous formula, from the previous formula, a formula that is we have, that is bandwidth is nothing but fmax minus fmin. Fmax minus fmin. Now we are going to calculate the bandwidth. So the bandwidth is given as your fc plus fm, that is the maximum frequency minus your minimum frequency. So we get it as twice that of your frequency of your message signal fm. So the bandwidth of the message signal, the bandwidth of the amplitude modulated wave is given as twice that of the frequency of your message signal. That is, bandwidth is nothing but your 2fm. Now, let us even define the same thing using your frequency representation. So here, whatever you see, the waveform, that is nothing but the spectrum of your amplitude modulated wave, which has both positive frequencies and negative frequencies. Now, let us see the upper sideband. So this is the carrier frequency, and whatever you see here, this is in the positive frequencies, this is the upper sideband, and we have a lower sideband here. So I can calculate my bandwidth using the upper sideband and your lower sideband. Now, what is that? So the maximum frequency in your spectrum is the frequencies which are above your FC. That is nothing but FC plus FM. This is the maximum frequency. And the minimum frequency is the frequencies which are below your FC, that is FC minus FM. So if you calculate that is FC plus FM minus FC minus FM, you'll be getting the bandwidth of 2FM. So similarly, we can also calculate it for the negative frequencies also. If you calculate the maximum frequency here is minus FC plus FM, and here the minimum frequency is minus fc minus fm. So when I calculate the maximum frequency minus the minimum frequency, if you do, then we'll get the bandwidth as 2fm. So thus, it can be said that the bandwidth requirement of the amplitude modulated wave is twice the frequency of the modulating signal, or else we call it as twice the frequency of your message signal or baseband signal. Now, let us go further and see what is the power consumed by the amplitude modulated wave. So, now let us consider the previous equation which we have taken as a standard equation, which contains the carrier, upper sideband and your lower sideband. So the total power consumed or the total power utilized by your amplitude modulator wave is the sum of the power consumed by your carrier or the power utilized by your upper sideband and power utilized by your lower sideband. So the sum of power consumed by your carrier, upper sideband and lower sideband is the total power which is utilized by your amplitude modulated wave. Now, let us do the mathematical analysis. Now, we know that the standard formula of the power of a sinusoidal signal or a cos signal, which is given as P is equals to Vrms square by R. So, where We can also write Vrms value as Vm by root 2 whole square by 2. This is the standard formula of the power consumed or power utilized by a sinusoidal signal. So where Vrms is the RMS value of the signal and Vm is the peak value of your signal. So with this basic information, we can proceed to calculate the power of the amplitude modulated wave. Now, first we'll find the carrier power. First, let us find the powers of your carrier upper and lower side bands one by one. So now from the previous formula, the carrier power is Pc is equals to Vrms square by R. So Vrms is nothing but your Vm, the carrier power, that is a cos signal, is it right? So that is AC by root 2 whole square by R. So Vm here, it is nothing but your AC by root 2, which is given as AC square by 2R. So this is the power consumed by your carrier. And similar way, if you look into the upper side band, so PUSB is nothing but the VM, the maximum voltage, that is VM is given as AC mu by 2 root 2 and as per the previous formula, so VM square by R, so AC mu by 2 root 2 whole square by R, which gives as your AC square mu square by 8R. So this is the formula or this is the power consumed by your upper side band. Similarly, the same power that is utilized by your lower side band is same as that of your upper side band, which is given as AC square mu square by 8R. So the total power which is consumed, the total power which is consumed is given as the sum of, it is given as the sum of the carrier power plus upper side band and the power consumed by the lower side band. Substituting that values here, we get PT is equals to, so by taking AC square by 2R as common from all the three terms, we are going to get AC square by 2R into 1 plus mu square by 4 plus mu square by 4. So that it gives us PT is equals to Pc into, that is carrier power into 1 plus mu square by 2. So this is the total power which is utilized by your amplitude modulated wave. So if you have your carrier power and if you have your modulation index, then we can calculate the total power which is utilized by your uh, amplitude modulated wave. Now, let us see if the modulation index value is equals to 1. So the modulation, if the amplitude modulated wave is having a modulation index less than 1, we have seen it is called as undermodulated. So if it is equals to 1, we said it as exact modulated. If it is greater than 1, we said it as overmodulated. Now, if the modulation index value, if you want an exact modulation, then modulation index is equals to 1. So what happens when the modulation index is equals to 1? Let us see now. So if the modulation index, is mu is equals to 1, then the power of EM wave is 1.5 times the carrier power. So that the power required for transmitting the EM wave is 1.5 times the carrier power for a perfect modulation. So if you look into this equation, that is PT is equals to PC into 1 plus modulation index is 1. So 1 by 2, which is equals to 3 by 2, sorry, PC into 3 by 2. That is, which is given as 1.5 times your PC. Okay. So this is what the total power consumed by your amplitude modulated wave. So on the other hand, if you look into this one, if PT is equals to 3 by 2 times your PC. PT is equals 3 by 2 times your PC. Now, let us see the carrier power, that is PC is equals to 2 by 3 times of your PT. That means you have the power consumed by your carrier is 66%. We can say it is 0.66 times of your total power, or in other words, we can also say that it is 66% of your total power. So only the carrier itself is consuming total 66% of the total power, and remaining 33.3% is utilized by your USB plus LSB. So USB plus LSB is utilizing total 33.3%. That means the carrier which is having no information when the amplitude wave is modulated, it is utilizing total 66% of the total power, which is the power which is going waste. So this is the drawback what we have with your amplitude modulated wave. So let us see some problems based on this one. So how your power is calculated in your uh, amplitude modulated wave with some examples. So here is one of the problem. So a modulating signal m of t is equals to 10 cos of 2 pi 10 power 3 t. So message signal he has given is amplitude modulated with a carrier signal c of t is equals to 10 cos of 2 pi 10 power 5 t, or finding the modulation index. He is asking us to find out the modulation index, the carrier power which is used, uh, utilized, and the power required for transmitting the AM wave. So he is asking us to calculate your modulation index and only the carrier power. So let us see what are the what are the parameters he has given. If you look at your modulating signal, so what is the given information? Let us see here. So the given information is m of t is equals to 10 cos of 2 pi 10 power 3. If you're comparing this one with your standard equation, we'll get the AM is equals to 10 here. The AM is nothing but the amplitude of your message signal is your 10 volts, and the frequency of your modulating signal, that is FM, is nothing but 1 kilohertz. So from the message signal, we got the modulating uh, signal frequency, that is FM, and your AM, the voltage of your modulating signal. Now, one more thing he has also given as the carrier wave. So in the carrier wave, he has given C of t is equals to 50 cos of 2 pi 10 power 5 t. So here, when I compare with the standard equation, the AC or the amplitude of your carrier, it is nothing but 50 volts, and you have the frequency is nothing but 100 hertz. The frequency he has given here is your 100 kilohertz. Now he is asking us to calculate the modulation index. So previously also we have seen the modulation index is defined as mu is equals to AM by AC, or we have also given here, that is A max, that is your A max minus A min by your A max plus A min. So as we don't know the maximum minimum frequencies, minimum amplitudes, so we only know the amplitude of your message signal and amplitude of your carrier signal. We are going to directly substitute these values and get the modulation index. So what we are going to do here, the message signal, amplitude of your message signal is given as 10, and the amplitude of your carrier signal is given as 50. So the modulation index is equals to 0.2. So if the modulation index is equals to 0.2, that means that your mu is less than 1, which is your under modulated wave. Under modulated wave. This is a under modulated wave. So this is under modulated wave. And now we need to calculate the power utilized by your uh, modulating signal, modulated signal. So we have, therefore we have here the modulation index is 0.2, which is under modulated, and the percentage of modulation which is done is 20%. So when we multiply the modulation index with 100, we'll be getting the percentage of modulation, which is 20%. Now, the carrier power, already we have given the equation of your carrier power, that is Pc is equals to AC square by 2R. So here we have taken and we have assumed that the resistance is of 1 ohm, and we are calculating the carrier power, that is AC is as given as 50. So 50 square by 2R, which is nothing but 1250 watts, or in other words 1.2 kilowatts. This is the carrier power which is utilized by your carrier in the amplitude modulated wave. Now, let us see uh, the total power which is consumed by the AM transmitting wave or modulated wave. So just now we have seen the formula, like PT is equals to PC into 1 plus mu square by 2. This is the formula to calculate the total power. As we know the modulation index, that is 0.2. If you substitute, the total power is 1275 watts. So if therefore the power required to transmit the AM wave is 1275 watts. In this, again you need to observe. So in this, the total power itself is 1275 in this. So what is the power utilized by your carrier? 1250 watts. That means only 25 watts is the power which is utilized by your sidebands. Only 1250 means here 1275. That is here 1275. So we have 1275 minus 1250, which is equals to only 25 watts. So 25 watts is the power which is utilized by your two sidebands. That means almost, as we said, 60% of the power. So total 250 watts of the power is getting wasted by transmitting the carrier which is having no information. So let us see one more example here. So here the equation of amplitude wave is given as S of t. So he has directly given here the modulating equation, that is S of t is equals to 20 into 1 plus 0.8 cos of 2 pi 10 power 3t into cos of 4 pi 10 power 5t. So he is asking us to find out the carrier power, that is Pc, and the total sideband power, that is PUSB plus PLSB, and the bandwidth of your AM. Now, from the given equation, if you look into what are the things we can take into consideration means, as we know that standard equation of S of t is nothing but we are going to compare here given equation with the standard equation. So when I compare, I will be getting the AC value, I'll be getting the modulation index value. I can take the frequency of your message signal and frequency of your carrier signal. So by comparing, I'll be getting the AC as your 20 volts, modulation index as 0.8, and the frequency of message signal is 1 kilohertz, frequency of your carrier is 20 kilohertz. Now, he's asking us to calculate the carrier power, the total power utilized by your upper and lower sideband, and he's also asking us to calculate your modulation index. So let us proceed. So as we know that the formula for the carrier power already we have seen, it is Pc is equals to AC square by 2R. So assuming that resistance is 1 ohm, we have got from your previous equation, we got the AC value as your 20 volts, and that we are going to substitute, and we are going to find out, that is 20 square by 2, or that is 20 watts is the carrier power. That means 20 square by 2R, which is 20 watts, is your carrier power. So therefore the carrier power is nothing but 200, sorry, 200 by, sorry, 20 square by 2, which is nothing but your 200 watts, is the power utilized by your carrier. Now let us proceed to calculate the upper sideband, lower sideband, and modulation index. The
Now,
equation as sideband power, so that is, we are going to express that one as Pc into mu square by 2. So that is sideband means both upper sideband and lower sideband. So substituting, as we have already calculated your Pc and mu values, so we will be getting the power utilized by the sidebands as 64 watts, and therefore the total sideband power is 64 watts, that is upper and lower sideband. So what is the bandwidth he's asking us to calculate? So bandwidth, already we said it is twice that of your FM. So already we know the frequency of your message signal, that is 1K. So the bandwidth is 2 kilohertz, which is given. So this is all about the bandwidth and power calculations in the amplitude modulated wave. So the bandwidth is twice that of your message signal, and the power utilized by your AM wave we are given as Pt is equals to 1 plus mu square by 2 into Pc. That is, if the modulation index is 1, then 1.5 times that of your carrier power is your total power. In other words, we can say that the carrier is utilizing 2/3 of the total power, that is 66.6% of the total power. So with this, we conclude this topic. So thank you.